All right, our next question, we have y cubed times z over 3 plus 2y. So again, we just have a rational expression plus 2y. And we know from prior knowledge that anything placed over 1 doesn't change the value of it. Same thing as saying anything divided by 1. So we can put this 2y over 1 if that helps us see a numerator and denominator, which it does for most students. So now I'm going to write this vertically. So I have y cubed times z over 3 plus 2y over 1. Okay, so let's find our common denominator between 3 and 1. Well, 1 goes into 3, so our common denominator is 3. So for this top fraction, y cubed times z over 3, our denominator stays the same, right? So our numerator should stay the same in order for them to be equal. That also just means that we're timesing it by 1. So we'll show that step just to show it, but if our denominator stays the same, our numerator should also stay the same. And here we have 2y over 1, and we want to know what that would be over 3. So to get from 1 to 3, we would multiply by 3, and we would do the same in the numerator. So I have 2y times 3, which is 6y. So I can add my numerators, because now my denominators are the same. So I have y cubed z plus 6y all over 3. 6y all over 3. All right, let's take a look at number 7. So we're adding these two rational expressions. They have different denominators. I have 2x over 3 plus 4 over x. So from our last video and also from this last problem, a way to find a common denominator is to multiply our two denominators. So for example, on this last one, we could say 3 times 1 is 3 and get that common denominator. So let's use that logic for this question here. Where to find a common denominator, I just want to multiply these two, because then for sure they're both factors of whatever that number would be, or term would be. So 3 times x would be 3x. Because 3 goes into 3x and x goes into 3x. So x goes into 3x 3 times, because x times 3 is 3x, and 4 times 3 gives us 12. Next here, 3 goes into x. What's this missing piece? 3 times what gives us 3x would be x. So we multiply the numerator by x as well. So we have 2x times x, which is 2x squared, or 2x times x. So we can add our numerators here. We have 2x squared plus 12 all over 3x. And we can't combine 2x squared and 12 because our 12 doesn't have an x squared. So this is our final answer for number 7. I'm going to try to squeeze in number 8 here. So number 8 is c plus 3 plus bc over 5. So I'm going to write it vertically again. Hopefully I'll have enough room here. If I have c, I'm going to place that over 1 plus 3 over 1 plus bc over 5. So we're going to use the same process. It's just instead of 2 fractions we're adding, or 2 rational expressions we're adding 3 of them. So we need a common denominator between 1 and 5. So we can multiply all of them. 1 times 1 is 1, times 5 is 5. So for sure, 1 and 5 are factors of 5. 5 goes into 5 once, and bc times 1 is bc. It's itself. 1 goes into 5 5 times. 3 times 5 is 15. 1 goes into 5 again 5 times. c times 5 is the same thing as 5c. So we can add our numerators. So we have 5c plus 15 plus bc all over 5. That's our final answer.